Hello and welcome to our Windows tutorial for installing the Debian Kiosk on our Spotify car thing. Without further ado, let's get into it. So I know I already went over what the Debian Kiosk is during our other Spotify car thing video, but a quick recap. On the Bishop Dynamics GitHub page, there is a pre-built Debian 13 𝗙𝗃𝐶𝐬𝐵 image designed specifically for the car thing. This image installs a Chromium-based browser in full screen kiosk mode, effectively turning the car thing into a dedicated web app interface. You can use this for things like Home Assistant control or any other kiosk style application. It replaces the default Spotify functionality and provides a full control via SSH, VNC, and the device physical buttons. Currently not working is Wi-Fi and GPU acceleration. Now, if we were to rebuild the bootloader, we could get these features to work, but that is more for a later date. Quick disclaimer, I'm not responsible for the bricking of your device. Follow this tutorial at your own risk. So now that we know what we will be installing, let's talk hardware prep. Now, it doesn't matter what version of Windows you're using, either Windows 10 or Windows 11, we're going to need the same thing: a laptop, desktop, or VM running Windows. We'll also need our Spotify car thing, its USB cable, an Ethernet cable, which is optional, a micro SD card, some device to act as a host like a RAD 𝗙𝗪, Rasp Pi S, Raspberry Pi 4, and a power cable for it. I will be using a Raspberry Pi 4B, by the way. Now, for our software. For tools, we need to download and install the ADB tools. Now, this is only needed if you want to get onto the shell of the Spotify car thing. You don't really need ADB tools, but they're nice to have. Next, we need to install Python. The latest version of Python should be perfectly fine. And after this is done, install any version of Git. Just make sure it's the 64-bit version. You may need to upgrade it inside the console line. Same can be set with pip. Just run the python.exe directory -m pip install upgrade pip. And then lastly, download 𝗙dig from the website. Now, real quick, for 𝗙dig, it's only needed if you haven't already flashed a different firmware onto your Spotify car thing. So if you've already done it, don't worry about 𝗙dig. It only changes the USB driver that the Spotify car thing uses, so we can read it on our Windows machine. We also need to install 𝗙𝗺𝐺, which you can do by downloading the zip file down in the description below, or you can just clone the repository in command prompt. You can do this by opening up command prompt, cd into our downloads folder, and type in git clone and then the 𝗙𝗺𝐺 GitHub page, and putting it in your Superbird tool folder, just like we have here. Just to make it easier, have your shortcuts to these programs either on your desktop or in a folder that we will have our files in. Speaking of files, after you've installed all those programs, we can get to downloading them. Now, we're also going to need to get the Superbird tool, the Debian firmware, Balena Etcher or Rasp Pi Imager. Those two will download later on when we cover those. And technically, we will also need the Raspberry OS Bookworm Lite image if we use Balena Etcher, but just like the other tools, we'll get to that later. You can get the Superbird tool from Thing Labs OSS, hit code, and hit download zip. The firmware under the Bishop Dynamics GitHub page, Superbird Debian Kiosk. Here on the right side, we're going to hit this and hit download for tar.gz. Once it's done, extract the Superbird tool main folder and then take the downloaded image file, OS, or firmware file of the Debian and then just right click and extract here. Now, due to the size of this file, it is going to take a little bit of time. And once that's done, just move it into the Superbird tool folder. And now that that's done, we can copy the location, open up a command prompt window, and cd into that folder. All right, now we're ready to flash that image file onto the Spotify car thing. So let's get to that first, and then we'll set up our Raspberry Pi. Now, final warning and disclaimer, this will remove everything on the Spotify car thing, similar to how we just flashed a different firmware. So let it do its thing, don't unplug it or turn off your PC because you might break your device. Alright, let's flash this firmware and we can get on to setting up our Raspberry Pi. Just like each time before, plug your Spotify card thing in, holding buttons 1 and 4, and wait for the chime. Now the screen should stay off. If you haven't already, open up Device Manager and check its USB driver for the Spotify card thing. It will have an unknown device called 𝐷𝗫𝗀𝐃. If you don't see it there, that's okay. Just launch 𝗙𝗵𝗺𝗀, hit Options, hit List All Devices, hit this drop down if it's not at the top, and hit 𝐷𝗫𝗀𝐃. If we want to install libusbk, you might have to cycle through this until you find the libusbk. Hit the Replace Driver button that will be here, and let it run its course. Once that's done, we can go back to our console window. You can type in Python /superbirdtool -- find device. Should pop up as USB mode. Now mine came up as USB burn mode. We'll get into that in a minute. But if yours doesn't pop up at all, make sure you set the correct libusbk driver for the Spotify card thing. Try another USB cable or USB port, and then rerun the script. Now we can run the same command, except this time run restore device, and then the directory for that firmware, so do /firmware, and hit the enter button. It's going to disconnect, reconnect. Now we don't need to enable burn mode or rename any of the file extensions. Everything has actually changed since our initial Flash tutorial. Everything was stated in our most recent Flash tutorial. Alright, while that runs its course, let's just talk about any issues you may have flashing the Spotify card thing. First, try another USB cable, another USB port directly on your system, no USB hubs, the Superbird tool in the description below, ensuring all these software tools are downloaded and updated, and then comment down below if none of these seem to work. Alright, while that runs its course, let's prepare our Raspberry Pi. Take your SD card and plug it into your computer. Make sure it's blank before you actually do anything, as it's going to remove all the data on the micro SD card. Earlier I said we can use Balena Etcher or Rasp Pi Imager. We'll start with Pi Imager, and then we'll cover everything with Balena Etcher. Using the link to the description below, go to raspberrypi.com, scroll down until you see install Raspberry Pi OS using Raspberry Pi Imager, click download for Windows. Once it's done downloading, just go through the setup process, and once it's done, open up Raspberry Pi Imager, select our device. I have a Pi 4B. Then for our operating system, we want Raspberry Pi OS, but we want Bookworm and Lite. So we'll go under Other, Raspberry Pi OS Lite 64-bit. And then for our storage, we have our micro SD card. Make sure you select the correct one. Last time, this will wipe everything. Click Next, and hit Edit Settings. Now for settings, here are the ones I highly recommend. Go to Services, enable SSH. Then for username, type in Pi and Raspberry. Configure your wireless LAN to your name and password, and then hit Save. Hit Yes again, and then let it run its course. While it does that, I'm just going to quickly touch upon why we chose those settings. Just using the default username and password tries to cut down on outside variables, trying to keep them all standard. Next is our network. Now, not everybody has access to the router or an Ethernet port, so we want to connect Wi-Fi to easily SSH in later. This does mean that we need to scan the network for the Pi's IP address. This can be as simple as downloading an app on your phone or PC. I highly recommend Angry IP Scanner and running that. Once the flash is complete, eject your SD card, plug it into your Raspberry Pi, and let it boot up. This initial boot will take some time. I suggest waiting at least 5 minutes until you scan the network or do anything. The Pi will reboot a few times during this. Now, whether you did the Wi-Fi setup or connected your Raspberry Pi to your router via an Ethernet cable, you can skip the timestamp on screen. Next up is our Balena Etcher setup. Following this, we'll also state how to set up local SSH. Speaking of Balena Etcher, you can open the application. If you don't already have it downloaded, just go to the website down in the description below and click Download Etcher. And then go to the Raspberry Pi OS website, link in the description below, and download the ISO file. We're pretty much going to do the exact same thing we just did with Raspberry Pi Imager, except we're just manually selecting the ISO file and burning it to our micro SD card. Now with everything downloaded, open up Balena Etcher and click on Flash from File. Click on the .xz file. You actually don't have to extract the image file out of it. Click on Select Target, and then select our microSD card. And then all you have to do is hit Flash, and you're good to go. Now, unlike Raspberry Pi Imager, we do need to open up the file system once it's flashed onto our microSD card and create a new text file, remove everything, and just put SSH. While we're here, create another text file. This time, name it 𝗙𝗹𝘀𝗵 but do CONF, and then just put your network credentials here under SSID and password. And this is just to enable Wi-Fi, so we don't have to worry about connecting it via Ethernet to our router or to our PC. Now we will still show how to set up by plugging it into our system, but we'll continue on with that. Now that that's done, save, close, and eject your microSD card. Plug it into your Raspberry Pi and plug in your Raspberry Pi to a power source and let it boot up. Now for Balena Etcher, you will need a keyboard and mouse to actually set up the device. Turns out a couple years ago they removed the default credentials for Rasp Pi OS. So if you want to set it up without a monitor, here on screen are the three screens that come up. First put a username in, then hit the enter button, then put your password in, hit the enter button, and then re-put your password in and hit the enter button. And then it should boot up and you should be able to do a local SSH or just plug into Ethernet and then you should be good to go. Now, I'm also going to mention that the 𝗙𝗹𝘀𝗵 file should also work, but if not, try the local SSH and set up Wi-Fi that way. Now, whether you did the Wi-Fi setup or connected your Pi to the router via an Ethernet cable, you can skip to the timestamp on screen, as now we're going to be figuring out our local SSH from your PC into the Raspberry Pi. Alright, so your Raspberry Pi is finished booting up. You've plugged your Ethernet cable from your Raspberry Pi into your PC. And now we need to connect our Raspberry Pi to the internet so we can then SSH into it that way. So there are two ways we can do this. If you used Raspberry Pi Imager and selected Raspberry Pi.local, we should be able to SSH in through Raspberry Pi.local. If that doesn't work, we will change our IP address to be static, and then we can SSH in through that specific IP address. Open up your network settings, hit change adapter options. All right, and right here we have our Ethernet plugged into an unidentified network. Double click. It's going to bring up this Ethernet status menu, hit properties, scroll down until we see IPv4, and then change this to 192.168.1.10, and then change the default gateway to 192.168.1.1. Hit yes. Let this be. We don't actually have to click through this. When you SSH the name that you put for your Raspberry Pi at 192.168.1.1. Alright, now that we are on the connected Raspberry Pi, let's connect this thing to the internet. Type in sudo raspi config, and it's going to bring us to this system settings. Hit system options, wireless LAN, enter in the SSID of the Wi-Fi network, and then you're going to enter in the password for the network. Once it's connected through, it's just going to kick you out to the main menu. Hit update if you want, and then just hit finish. And now the Raspberry Pi is connected to the internet on the Wi-Fi network. Now we just need to reboot the Raspberry Pi, scan our network for its connection on Wi-Fi, and reset our wired connection. Just change it from manual to automatic, and then we'll be good to go. Now local SSH doesn't always work, so if that's the case, I was just using the 𝗙𝗹𝘀𝗵 file and connecting to Wi-Fi. Now real quick, if you've done everything and your device still won't connect to the internet, try using a different version of the Rasp Pi OS and maybe use Balena Etcher instead of Raspberry Pi Imager. Alright, now that our host device has booted up and connected to the internet, let's actually get this thing set up. Open up a terminal window and SSH into the Pi using pi in the IP address of your Raspberry Pi. Type in yes for fingerprint, and the base password will be raspberry, all lowercase. And now we're on our Raspberry Pi. We can type in sudo apt install and git. If it's not already installed, just run through the setup process. If it gives you any issue, just type in sudo apt-get install git. And next up, we can clone the repository. Type in sudo git clone. And then the easiest way is to just copy the link in the description below. Or if you need to, go back to your web browser, go to the Bishop Dynamics GitHub page, 𝗙𝗵𝗺𝗲 Debian Kiosk, and copy this link. Paste. And hit the enter button. The download won't be too large, as just right there, it finished. Let's cd into the 𝗙𝗵𝗺𝗲 folder, just downloaded, and type in sudo bash setuphost.sh. Now it's going to set up the host device to actually run our Spotify card thing. Now the setup process isn't too long, 2 to 3 minutes, depending on your network speed. Alright, now that it's done, it has added the following IP address of 192.168.7.2 𝗙𝗵𝗺𝗲 into our host, which this will be our Spotify card thing. Now that that's done, just type in sudo reboot, and it's just going to reboot our Raspberry Pi, and that concludes our Raspberry Pi setup. By now, our Spotify card thing should be more than done flashing. We can unplug it from our PC and plug it into our Raspberry Pi. Now there are 3 boot modes that the new Spotify card thing has. Holding the first button puts the device into ADB utility mode. Holding button 4 puts the device into USB burn mode. And then no buttons at all is its default boot option. We're going to stick with the default boot option for this. Once it boots, we should be at the Chrome screen with the failed attempt to connect to an IP address website. SSH into our Raspberry Pi with our default creds of Pi and Raspberry. Now here's where things get a little tricky and might not always work. SSH into our Spotify card thing, doing SSH 𝗙𝗵𝗺𝗺 or 𝗙𝗵𝗺𝗺@192.168.7.2, and the password is 𝗙𝗵𝗺 in all lowercase. If you're not able to get on it, you do need to type in sudo root add net 192.168.7.0 netmask 255.255.255.0 dev USB 0, and then you're able to actually SSH onto this. I actually spent quite some time trying to figure this out. If you can't get onto it, let me know down in the comment section below. I'll try my best to assist you. But now that we are onto it, why don't we check out what we can actually do. First up, we're going to cd into our scripts folder. Just type in cd:\scripts. Now that we're in our scripts folder, let's go into Chromium settings.sh. And here is the URL that we see in the beginning when it says, this site cannot be reached, 192.168.1.144, the port, and then Lovelace. All we need to do is change this to pretty much anything for it to connect to that specific site. Now this is more for home automation or anything you want to use that the Raspberry Pi can connect through. We're just going to put Google here to check it out. Hit Control S, Control X, and then we're just going to reboot this by doing sudo systemctl restart chromium.service. It's going to restart our Spotify card thing, and then it's going to boot up into Google. Now we can even touch on Google and everything for trending searches will come up, but the keyboard does not want to come up in this state, which, I mean, it makes sense. Now there are multiple things we can do. We can change the button settings. We can also change the default screen timeout, the default orientation, the backlight for brightness, and then also change the VNC password. Now there are a lot more to this, but those are the ones we're going to take a look at first. So we're going to check out the button settings by going to nano buttons settings.py. Now here's everything that you're going to need to modify each button. Here's just an example for the Home Assistant address, the token for it, and pretty much everything else that Bishop Dynamics used in his example for the GitHub page. Now this isn't limited to just this. It just shows, for example, that this is what you want to do to modify the buttons. If we exit out of this and go into X11 XORG, here we have the just basic XORG configuration for the 𝗙𝗵𝗺𝗺, and here's where the default orientation will be. Now portrait is the current orientation with the buttons on the right side. If we scroll down to lines 38 and 71, here is the option to rotate. So you would just uncomment this, and then 71, uncomment this, hit Control S to save and Control X. Now I did not do this under sudo, so it's not going to actually write this. And then just restart Chromium once again, and it's going to put it into landscape mode. Now one more thing I do want to check out is the adjustment for backlight brightness. Now to modify the brightness of this Spotify card thing, we're going to do nano scripts setup display.sh. And under here, we can see the setup mode, the default portrait orientation, and everything else modifiable for the user. And then if we do backlight instead of display, here we can see the basic default brightness went on, how often to check the state of the display, and then the control for the brightness. Now, if you're looking for the screen timeout, I did say it is under the xorg.config. And here's the default standard basic timeout. You would just modify these values. And that's it. All the documentation for specifics can be found on the GitHub page itself. Now, I like this because it leaves a lot to create your own off of this, especially since it has touchscreen functionality, buttons, and pretty much everything seems to work, unlike our previous Debian CH root. But that was the start, and this is better. Now don't forget, these are all proof of concepts. They're not always going to work. I always try to add the fix that I find into these videos. For example, again, if it doesn't work, just put the command on screen to add that value. If you have any issues, just let me know down in the comment section below. I will try to assist you as best as I can. Now, if you found this tutorial helpful, even in the slightest, consider subscribing for content like this. Like if you like, dislike if you dislike it, and I'll see you all in the next video.